In today's session, we'll discuss numerical methods 1. Here we'll be discussing about Newton's Raphson's method. Approach. This is the formula we'll be using, iterative formula. Here this is xn plus 1 is equal to xn minus f of xn divided by differentiation of this, which is f dash xn. So here the thing which you have to understand is, here we have taken xn plus 1 and here the value is n, so 1 less than this. So this you have to remember in the formula. Okay, now if the root exists between a and b, then the initial approximation x naught can be taken either as a, b, or any point between a and b, or a plus b by 2. Here suppose if you are taking for n is equal to 1, that is here if you are taking n is equal to 1, then it will become x1 is equal to x0, x0, that is 1 less than this, minus f of x0 divided by differentiation of this function, which is f dash of x0. So this is the first approximation. Next we have to iterate again. Then next we have to keep n is equal to 2. Here the x will become 2. Here n is 2. So x is 2 is equal to x1, because here when n plus 1 is given here, it becomes here n, that is 1 less than this. So here x2 is equal to x1 minus f of x1 divided by f dash of x1, that is differentiation of this, and we'll get the second approximation. We have to keep iterating it till we get two consecutive numbers are same. Okay, let's understand this clearly with an example. Here, find the root of following equation by Newton-Raphson method. Here this is the equation, and here they've given the approximation two cases. In one, x is equal to 0.5, and in the other case x is equal to 2. Let's solve this. So we'll keep this is a equation given. We'll call this equation as f of x. Next step, we have to differentiate and find f dash of x. So here x cube will become 3x square minus differentiation of 3x is 3. So this is the value of f dash. Okay, and we know the formula is xn plus 1 is equal to xn minus f xn divided by f dash xn. So here in first case x is equal to 0.5. So we have to keep x naught is equal to 0.5. Now let's start the iteration. For first approximation, we have to keep x1 is equal to x naught. Here x naught is 0.5. So here this f of x naught, that is here f of x value is here, and in this we have to place the value of x naught, that is 0.5, and we get this. Now divided by f dash x naught. This is f dash value, and here we have to place the value of x naught, which is 0.5, and we get this, that is 3. Here x square is 0.5 square, here minus 3 minus 3. On simplification, you get 0.33. Here we can use calculator to solve this. It will be easier. Then second approximation is equal to second approximation is x2 is equal to x1 minus f x1 by f dash x1. Here the x1 value is this. Okay, so that value we have to substitute here. F dash x1, that is here f of x is here. Now, so here we have to place the value of x1, which is this. So we get this value divided by f dash x1. This is f dash value. Here we have to place the value of x1, which is this. So we get this. On simplification, we get 0.34. Now we have to carry out next iteration. Here x3 is equal to x2 minus f of x2 by f dash x2. Here x3, x2 value is this, is x2 value, we are placing it here, minus f f of x, this is f of x, here f of x2 is there. So in the value of f of x here, we have to place the value of x2, which is 0.34. So we get this divided by f dash x2, that is in f dash value you have to place the value of x2, which is 0.037. So here 3, here we are placing the value of x2, then here minus 2. On simplification of this, we get 0.347. Here we have to see this value and this value are same. So we'll stop the iteration. And the approximation root is this. Now we'll take the case where x is equal to 2. Here, for first approximation, x1 is equal to x naught minus f x naught by f dash x naught. Here, x naught value is 2. So we are placing the x naught value here 2. And then in f of x, we have to put the x naught value, which is x cube will become 2x cube minus 3x will become 3 into x plus 1 divided by f dash value, f dash x naught. So in f dash x value, we have to put the value of x naught, which is 2. So which comes 3 2 square minus 3. On simplification, we get 1.66. Now we have to carry out second approximation. Here x2 is equal to x1 minus f of x1 by f dash x1. So here x1 value is 1.66, which is this, minus here f dash f of x1 value. In this f of x value, you have to put the value of x1, which is this. Then f dash x1, we have to put here the value of x1. So here it comes 3 into 1.66 square minus 3. On simplification, we get this. Then we have to carry out third approximation. x3 is equal to x square, sorry, x3 is equal to x2 minus f of x2 by f dash x2. So here putting the value of x2 here, we get here, after substituting the value of x2, we get this. On simplification, we get this. Now we have to carry out fourth approximation. Same thing, x4 is equal to x3 minus f of x3 by f dash x3. So x3 value we have to get it from here. We'll put x3 here minus here f dash, sorry, f x3. So in f of x, we have to substitute the value of x3, which is this. We get this. And then f dash x3, in f dash x value, we have to substitute the value of x3, which is this. We get this. On simplification, we get 1.532. Now we see these two values are same, so we have to stop the iteration, and the approximation root is 1.53. Example 2, find the real root of following equation by Newton-Raphson's method. Cos x is equal to x e to the power x, which is nearer to x is equal to 0.5, correct to 3 decimal places. So this is the equation, and we'll call this as f of x. Next we have to differentiate it and find f dash x, and the cos x will become, on differentiation, minus sin x minus here x and ex. So here product rule of differentiation is used. First we'll keep this x as such and differentiate ex. Differentiation of ex is ex plus. Now we'll keep this ex as such and differentiate x. Differentiation of x is 1. So we get this value as f dash x. This is the Newton-Raphson's formula we know. Now here we have to start with keeping x naught is equal to 0.5. Okay, so first approximation, x1 is equal to x naught minus f x naught by f dash x naught. Here x naught value is 0.5. f of x naught, that is in f of x value, you have to place the value of x naught, which is 0.5. So we get cos 0.5 minus 0.5 into x to the power 0.5 here, this. And then f dash x naught. So here in f dash value, we have to place the value of 0.5. That is minus sin 0.5 minus 0.5 e to the power 0.5 plus e to the power 0.5. And this we have, on simplifying, we get this. We can use calculator, and remember, while using calculator, turn it into radian mode. Okay, then we have to carry out the second approximation. x2 is equal to x1 minus f dash x1 by f dash x1. So here x1, in this we have to place the value of x1, which is 0.518, and here f dash, we have to place the value of f will place the value of x1 in this. Okay, so we get x2 is equal to 0.518 minus cos 0.518 minus 0.518 e to the power 0.518 divided by minus sign 0.518 minus 0.518 e to the power 0.518 plus e to the power 0.518. On simplification, we get this. Now here we say this and this are same, so we can stop the iteration and we get the approximate root is 0.518. Let's see another example. Find the real root of following equation by Newton-Raphson method. X sin x plus cos x is equal to 0, which is nearer to x is equal to pi, correct to 3 decimal places. So this is the equation. We'll call this equation as f of x. Now we have to differentiate and find f dash x. Differentiation of x sin x. So now we'll keep this as such, x as such, and differentiate sin x, which becomes cos x. Now we'll keep this sin x as such and differentiate x. Differentiation of x is 1. So we'll get sin x. Okay. And now this term cos x, differentiation of cos x is minus sin x. So we get this. Here plus sin x and minus sin x will get cancelled. So f dash x value is x cos x. This is the equation we know. Now we have to start the iteration, keeping here it is given x is equal to pi. So here we'll put the x naught value pi. So x1 is equal to x naught minus f dash x naught by f dash x naught. So here x naught value is pi. We'll put the value of x naught here as pi, and in f x naught, that is in f of x value, we have to put the value of x naught, which is pi. So we get this. And similarly for f dash x also, you have to substitute the value of pi. We get this. On simplification, we get this. Now we have to start the second approximation, keeping this x1 value here. So x2 is equal to x1 minus f dash x1 by f dash x1. So here we have to place the value of x1. x1 is 2.833 minus here f of x. In f of x value, here f of x1 is there. So in f of x value, we have to put the value of x1, which is 2.8233. Similarly, here for in f dash x, we have to put the value of x1, which is 2.8233. So here we get x is 2.8233, cos is there, and again x value is 2.8233. So on simplification, we get this. Now we have to carry out next iteration, keeping x2 value this and substituting the value, we get this. Again we have to do again the next iteration and substituting the value of x3. We have to take the value of x3 which we got from here. Here we are placing the value here x3, and in the formula in f of x we have to place the value of f3. We get this. And similarly for f of f dash x, we have to place the value of x3. We will get this. On simplification, we get 2.798. This value and this value are same, so we can stop the iteration, and the approximate root is 2.798. Example 4. Find the real root of following equation by Newton-Raphson's method. 3x is equal to cos x minus 1, correct to 3 decimal places. Solution. So this is the equation. We'll take this as f of x. Now we have to find f dash x, that is we have to differentiate this. So 3x will on differentiation becomes 3 minus cos x, differentiation is minus sin x, so minus plus, we get plus sin x. Differentiation of 1 is 0, so this term will become 0. So f dash x is equal to 3 plus sin x. Now here the near value is not given, we have to calculate it. So we have to first put 0 and see the value. So when we put the value 0 here, so 3x will become 0 minus cos 0 minus 1. So here cos 0 is minus 1. So 0 minus 1 is minus 2. Now we have to put f of 1 is equal to 1 into 3 is 3 minus 1. So cos 1 minus 1. So we get 3 minus 0.54 minus 1, which is equal to 1.46. Now here we see, here we got one minus value and one plus value. So the root lies between this two. So here we have to see that we have to take the modulus of f of 0. When we take modulus of f of 0, that is 2. And similarly, modulus of f of 1 is 1.46. So here we understand that modulus of f of 0 is more than modulus of f of 1. So whichever is less, we have to take. Therefore, the required root is near 1. That is this one, f of 1, this one. So let x naught is equal to 1. This is the equation given. Now we'll start iteration. X1 is equal to x naught minus f of x naught by f dash x naught. Okay. Now value of x naught is 1. So substituting the value. Here we got the value of x naught as 1. We have put it here. And f of x, this is f of x. Here we'll put the value of f naught, that is which is 1. So we'll get 3, 1 minus cos 1 minus 1 by f dash value. Here we have to put the value of f naught, which is x naught, which is 0, sorry, which is 1. So 3 plus sine 1. On simplification we get this. Remember to while using calculator you have to turn it into radian mode. Now second iteration we have to do, x2 is equal to x1 minus f of x1 by f dash x1. So here the value of x1 is given here. We have to put the value of x1 here, this value. And on simplification we get this. Now we'll start with the third approximation. x3 is equal to x2 minus f of x2 by f dash x2. So here x2 value we have already got from here. We'll put the value of x2 here and then substitute in these two. And after simplification we get this. So now we see this value and this value are same. So we can stop the iteration and the approximate root is 0.607. Example 5. Find the real root of following equation by Newton-Raphson method. Here x log x to the base 10 is equal to 1.2. In 2 comma 3 correct to 4 decimal. So this is the equation here. We have to bring this 1.2 this side. So we'll get x log x to the base 10 minus 1.2 is equal to 0. Okay, and that value we have to take it as f of x. So this we are taking it as f of x. So next step is we have to differentiate it. When we differentiate it, this x and log x, this is a product. So here product rule of differentiation is used. So first we'll keep this as such and differentiate x, which is 1. So log x to the base 10 will get plus. Now we'll keep this x as such and differentiate log x to the base 10, which is 1 by x log e to the base 10. So on simplifying, that this and this will cancel. On simplifying we get f dash x is equal to log x to the base 10 plus log e to the base 10. Okay. Now here it's given 2 and 3. So the given root is between 2 and 3. Okay. Now we'll put the value for 2. F of 2. When we put the value of 2 here, we get 2 log 2 to the base 10 minus 1.2. On simplifying, we get minus 0.598. Now we have to put the value of 3 here. So 3 log 3 to the base 10 minus 1.2. On simplifying, we get 0.23136. Now this value here, this is negative and this is positive. So we got negative and positive. So the root lies between these two. Okay. Now here modulus of f of 2 is more than modulus of f of 3. See here when we take modulus, we know 0.5 here it is given, in 0.2 it is here. So 0.5 is more. So this is more than this. So therefore the required root will lie near whichever is less. So here in this case f3 is less, so it will lie near 3 here. So x naught is equal to 3. Now we have to calculate this. X1 is equal to x naught minus f of x naught by f dash x naught. So substituting the value here, x naught value is 3. So we'll put the value here, and f of x, in this we'll put the value of x naught, which is 3. We get this. And then f dash x naught. So here we'll put the value of x naught, which is 3. So we'll get this. On simplification, we get 2.746. Now we have to start next iteration. So x2 is equal to x1 minus f of x1 by f dash x1. So here x1 is this, is minus f x1, this value. Here we have to put the value of x1, which is 2.746. So here after substituting the value we get this, divided by f dash x1. So in f dash we have to put the value of x1, which is this. Okay, so after substitution we get this. Simplifying this, we get 2.7406. Now we have to start with third iteration. So x3 is equal to x2 minus f of x2 by f dash x2. So here the x2 value is this. Substituting the value and simplifying, we get 2.7406. Since these two values are same, we have to stop the iteration, and we got the approximate root is 2.746. Now here in the example 6, find the fourth root of 32 using Newton-Raphson's method. Here hint they have given, we have to take x to the power 4. Fourth root of 32, so we have to take x to the power 4 minus 32 is equal to 0. Okay, let's see how to do it. So here they have given fourth root of 32. So fourth root x is equal to fourth root of 32. So now f of x is equal to this 32, you bring it this side. Okay, so x minus fourth root of 32. This can be written as x to the power 4 minus 32. That is squaring here. Okay, we get this. Now we have to find f dash of x. So on differentiating this will become 4x cube minus 0. So f dash x will be equal to 4x cube. Okay, so now we got f dash of x, f dash x value and f of x value. Now here near root is not given, so we have to calculate it. First we'll take f of 0. So when we put f of 0 here, so it becomes 0 minus 32, which is minus 32. Then we'll take the value of 1. Then it will become 1 to the power 4 minus 32, which is minus 33. Then we have to try with the value 2, which is 2 to the power 4 minus 32 is minus 16. Then we are taking the value 3 to the power 4 minus 32, which is 49. Now here we got these two values, minus value and positive. So here the root lies between f of 2 and f of 3. Okay, so here in between these two, when we take modulus, which is less, when we take modulus of this, f of 2 is less. So the required root is near 2. So here we will be taking x naught value as 2. So this is Newton's formula. We have to substitute in the formula. X1 is equal to x naught minus f of x naught by f dash x naught. Here we have to substitute the value of x naught, which is 2. So after substituting the value, we get simplify this, and simplifying we get 2.5. Now we have to start with next approximation. So x2 is equal to x1 minus f of x1 by f dash x1. So here x1 value we have to substitute. In f of x also we have to substitute the value of x1. F dash of x, we have to substitute the value of x1. We get this. Simplifying it, we get 2.387. Now we have to do third approximation, that's x3 is equal to x2 minus f of x2 by f dash x2. So here we have to substitute the value of x2. which is this. We will get this, and on simplifying we get 2.378. Now again we have to carry out one more next approximation, fourth approximation. That is x4 is equal to x cube minus f of x cube by f dash x3. So here substitute the value of x3, which is this. So here we got this value x3 we have to substitute in f of x, we get this f dash of x3. Here substituting the value of x3 we get this. On simplifying we get 2.378. This value and this value are same, so we have to stop the iteration, and the approximate root is 2.37.